You've definitely seen images like this when learning about our galaxy, the Milky Way. But here's the thing, not a single one of those images is a real photograph. Every last one of them is an artist's illustration. Because forget photographing the Milky Way from the outside. When we look up at the night sky with our naked eyes, every star we can see fits within this tiny red circle. That's because the naked eye can only see stars a few thousand light years away. And a few thousand light years is a laughably small fraction of a galaxy that stretches over 100,000 light years across. To put that in perspective, the Kepler Space Telescope, launched in 2009 and operational until 2018, discovered 2,778 exoplanets over its entire mission lifetime. And all of those were packed into a search area of just 3,000 light years. So if we can barely scratch the surface of our own cosmic backyard, how on earth do we know what our galaxy actually looks like? Trying to figure out the shape of the Milky Way from the inside is a lot like being lost in an enormous forest and trying to draw a map of it. It sounds impossible at first, but it's really not. After all, back around 200 BCE, the ancient Greek scholar Eratosthenes not only figured out that the Earth was round, he actually calculated its circumference with remarkable accuracy. We can do something similar with our galaxy. And don't worry, in this video we're not going to drown in complex physics equations. Instead, we're going on a genuinely fun journey through the depths of the universe. If you've ever been somewhere truly, completely dark, no city lights, no street lamps, nothing, and looked up at the sky, you've probably noticed it. A faint, hazy band of light arching across the entire sky like a giant, glowing river. Humans have been staring at this thing for thousands of years, trying to make sense of it. The ancient Greeks believed it was the milk that sprayed from the goddess Hera's breast, which is actually where the English name Milky Way comes from. Different cultures, different stories. The Egyptians thought it was a river of cow's milk, while Australian Aboriginal peoples saw it as a river flowing across the sky. Today, of course, we know exactly what it is. A small slice of one of the spiral arms of our galaxy, made up of over 100 billion stars. And here's the fascinating part. Even without any complex math, just by looking at that glowing band, we can already start making educated guesses about the shape of our galaxy. We can't step outside the Milky Way and look back at it, but we can observe other galaxies. And when we do, we basically see three types: elliptical galaxies, spiral galaxies, and irregular galaxies. Our galaxy has to be one of these, and the question is, which one? Here's the key clue. If we lived in an elliptical galaxy, stars would be spread roughly evenly across the entire sky in every direction. We'd never see a concentrated band of light like the one stretching overhead. The same goes for irregular galaxies. But that bright, concentrated arc we see? It tells us we're living inside something flat. Not a sphere. A disk. And we can actually confirm this by looking at other disk-shaped galaxies from different angles. Take M51, the Whirlpool Galaxy. Its disk is facing almost directly toward us, so we're looking straight down at it, and we can clearly see its spiral arms. M81 is similar, but tilted at a slight angle. The Andromeda Galaxy is tilted even more, but we can still make out its spiral structure. The Sombrero Galaxy is seen almost perfectly edge-on. We can barely see any spiral arms, but the flat disk shape is completely undeniable. Want to see what a galaxy looks like from perfectly edge-on? NGC 891, about 30 million light-years away, is your answer. Seen exactly from the side, there are no spiral arms visible whatsoever. But you can clearly see a central bulge where stars bunch up toward the middle and thin out toward the edges. That bulge alone is strong evidence that it's a spiral galaxy, even without seeing the arms directly. Now, back to our own galaxy. We can only see a tiny piece of the Milky Way from where we stand. To get the full picture, we need to observe the entire sky. Our eyes can't do that, but space telescopes can. The Gaia satellite scanned the entire sky in 3 dimensions between 2014 and 2016. When that data was converted into a panoramic image, it showed us the most detailed view of the Milky Way ever captured from our vantage point. And if you look at it next to NGC 891, I think you already see where this is going. The resemblance is not a coincidence. Both images show a flat structure with a clear central bulge. Combined with everything we know about galaxy types, this tells us, confidently, that the Milky Way is a disc-shaped spiral galaxy. That central bulge isn't just a visual feature either. When we point telescopes toward the very center of our galaxy, we see gas clouds moving at nearly 30% the speed of light, and stars orbiting around something invisible. The only thing that could pull matter around with that kind of force is a supermassive black hole, specifically one with a mass about 4 million times that of our Sun. That's Sagittarius A star, and yes, we've actually managed to photograph it in recent years. So, when we see that central bulge in our galaxy map, and we know there's a supermassive black hole sitting right there, the spiral galaxy conclusion becomes even more rock solid. Now that we know roughly what our galaxy looks like, the obvious next question is, where exactly are we inside it? The first serious attempt to map the galaxy came from the astronomer William Herschel in the 1780s and 90s. He divided the sky into 683 regions and manually counted the stars in each one. His logic was sound. If stars get denser toward the galactic center and thinner toward the edges, the distribution of stars across the sky should tell us where we are. But when Herschel looked, the star density seemed roughly the same in every direction, which led him to conclude that the Sun was sitting right at the center of the galaxy. We now know that map was wildly wrong. The reason? Herschel had no idea that the center of the Milky Way is packed with interstellar dust and gas that blocks visible light. All those stars he should have been counting near the center were completely invisible to him, hidden behind clouds of cosmic dust. He was essentially trying to see through a wall without knowing the wall was there. That said, his map wasn't entirely useless. It did correctly suggest that the galaxy was disc-shaped. So partial credit. Now, here's another important detail worth mentioning. Until the early 20th century, scientists believed the Milky Way was the entire universe. Everything in the sky, including what we now know are other galaxies, was just called a nebula, meaning a cloud, and assumed to be somewhere inside our own galaxy. Some astronomers, like Haber Curtis, argued that certain nebulae were actually entire galaxies far outside the Milky Way, but nobody could prove it because nobody could figure out how far away they were. That all changed thanks to a brilliant astronomer named Henrietta Swan Leavitt. She discovered that certain stars called Cepheid variables pulsate. They expand and contract in a regular rhythm. And she noticed something remarkable. There's a direct relationship between how fast a Cepheid pulses and how intrinsically bright it actually is. This was a game changer. Here's why. Imagine a candle 1 meter away from you. You know exactly how bright that candle is up close. Now move it farther away and it gets dimmer. If you know the candle's true brightness, you can calculate how far away it is just from how dim it appears. Leavitt essentially gave astronomers a standard candle they could use across cosmic distances. Astronomer Harlow Shapley was clever enough to apply this technique to globular clusters, which are dense balls of hundreds of thousands of stars packed into relatively small regions of space. Messier 80, for example, contains hundreds of thousands of stars in a sphere only 96 light-years across. Shapley mapped the distances to these clusters and noticed something important. They weren't evenly spread across the sky. They were concentrated in the direction of Sagittarius, the Archer constellation. This was the first real clue that we are not at the center of the Milky Way. If we were at the center, globular clusters should be spread evenly in all directions. But they weren't. Shapley calculated that the galactic center must be somewhere in the direction of Sagittarius, roughly 50,000 light-years away from us. That number was a bit of an overestimate. Modern measurements put us about 26,000 light-years from the center. But the direction was exactly right, and that's where Sagittarius A star, the supermassive black hole we talked about earlier, actually sits. Now we knew the general shape and our rough position in the galaxy. But how did we figure out the details, the spiral arms? This is where our old enemy makes a return. Interstellar dust. Going back to the forest analogy, imagine trying to map a huge forest while standing inside it, with thick fog blocking your view in every direction. That's what it's like trying to map the Milky Way in visible light. The dust and gas in the galactic plane absorb and scatter visible light, hiding huge portions of the galaxy from us. But here's the workaround. Radio waves and infrared light pass right through that dust, as if it isn't even there. So telescopes sensitive to those wavelengths can see things that optical telescopes simply can't. This is actually how we were able to photograph Sagittarius A star using radio telescopes. The birth of radio astronomy in 1933 opened up an entirely new window onto the galaxy. In the 1950s, astronomers used radio telescopes to map regions of gas and dust where new stars were being born. And that turned out to be one of the best ways to trace spiral arms, because as the galaxy rotates, the gas and dust in those arms gets compressed, triggering the birth of new stars. So wherever you find young stars in high concentrations, you're almost certainly looking at a spiral arm. Early observations using this method suggested 4 major spiral arms. But in 2008, the Spitzer Space Telescope, designed to observe in infrared, studied 110 million stars in our galaxy and found that the Milky Way likely has 2 primary spiral arms with several smaller secondary ones. Data from the Gaia telescope, which is still operating today and has measured the distances and velocities of over 1 billion stars, supports this picture. Based on all these observations, our solar system sits between 2 of the main spiral arms, the Perseus arm and the Sagittarius arm. But that doesn't mean we're just floating in empty space between them. We're actually located within a smaller structure called the Orion Arm, a minor spur roughly 3,500 light-years wide and about 10,000 light-years long. So the next time you find yourself somewhere truly dark and you look up to see that faint, hazy arc stretching across the sky, remember what you're actually looking at. That glowing smudge is a tiny sliver of one small arm of a spiral galaxy over 100,000 light-years wide. For most of human history, people looked at that same arc and told stories. Milk from a goddess, a celestial river, a sign of the divine. Some looked at it and felt confirmed in the belief that we were at the very center of everything. But today, that same glowing band tells us something far more humbling. Not only are we nowhere near the center of the universe, we're not even particularly central within our own galaxy. We're on the outskirts of a minor arm of an average-sized spiral galaxy in a universe of hundreds of billions of galaxies. And honestly, that's not a sad thought. That's one of the most extraordinary things our species has ever figured out.